This is Chinese group. We are doing carpenter's helper. This is Gordy, this is Russell, and this is Luke Chow. Now I'll be explaining question 1. You have to make a brace for a door that is wobbling. You are going to use a diagonal wire brace. The door is 8 meters high, and 3 meters wide. How long should the brace be to make sure that the corners of the door remain square? Making a brace. We have labeled the points on the rectangle to be A, B, C, D. The diagonal is AC. So we use the cosine rule and found the diagonal. So we use B square equals to A square plus C square minus 2AC cosine B. What? Yeah. So with the cosine rule, we have found that the diagonal is actually 8.54 meters in 3SF. Yes. Now I'll pass it on to Gordy with the. Okay, I'll pass it on to Russell.
Question 2. You have to help the carpenter decide how long to cut the boards to make a roof. You know that the angles where the sides meet the chop is 90 degrees, and that the angle where they meet the house has to be equal. The width of the house is 8 meters. At what angle does the roof meet the house, the side of the house, and how long should each side be of the roof be? As you can see through our diagrams, you can see the length of the roof is in a triangle shape. We have labeled it ABC, and 8 being the longest side. We've also deduced that the two other sides are isosceles.
A is the hypotenuse. A is the hypotenuse. Okay, you see, angle ABC. Angle roof means the side of the house. So now we have used the sine rule. You see, A over sine A equals to B over sine B. Then applying the values, we have found that the length is 5.66 meters in 3SF. Now Russell will pass it on to Luke for the third question.
Okay.
Come on, Luke.
For third question, we are tasked to design a handicap ramp for a new office building. And it's mentioned that by law, the ramp has to be 7 degrees from the ground. And the porch it leads up is 3 meters above the ground. So we have to find out how far the ramp will extend from the building and how long the ramp has to be. So we have drawn a diagram from the office. Here's the office and the ramp. As you can see, the ramp resembles a triangle, a right angle triangle, 3 meters above the ground, and the 7-degree inclination. So on the ramp, we have marked out 3 points, A, B, and C, and we can easily deduce that we use the sine rule, which is B over sine B is C over sine C. So we simplify the answer and we can get the answer, and then now we have to find the angle. And using sine rule again, A over sine A is C over sine C. We can find A, which is how long the ramp has to be.
How long?
Yeah. Let's see.
Okay. Now Luke will pass it on to Gordy. This guy Gordy here.
Okay.
Question 4.
Question 4. Your boss forgot his tape measure today, but you need to install molding into a triangular room in which one corner is 90 degrees. The wall opposite the 90-degree angle has the same length as the 10-meter ladder. Yesterday, the carpenter measured one corner to be 63 degrees. How long should you cut the other 2 pieces of molding? How wide is the other corner? So, this is our solution. Okay, we have drawn a sketch of the triangle to show that we are going to work out from that. So first I found out the angle. Since they said that one of the angle is 63 degrees and 180 triangle is 180 degrees. So I use 180 minus 90 and 63. So I find the other angle. So the other angle is 27 degrees. So now what I'm trying to do is to find the length of each side. So first I'll use the sine rule, the sine trigo ratio, and then I find each of the sides. So first I use the sine ratio to get the side of the opposite angle of 63 degrees. Next I use the cosine ratio to find the length, to prove that the length is correct. So as you can see, I did two workings to prove that this is the same length. So next I use the tangent trigo to find, using 27 degrees to find the other length. So as you can see, I did two also to show that each of it has the same length, which proves that the length I got is correct. So my statement will be the two lengths are 8.91 meter and 4.54 meter.
This concludes our video of trigonometry, AMOA. Awesome. Okay, bye.